Hi there, in this video I'm going to be proving the inverse hyperbolic tan function. Okay, so let's go for it. So result number 3, underline that. So the inverse hyperbolic tan has the definition or the result 1 over 2 ln 1 plus x divided by 1 minus x, and that is true when the modulus of x is less than 1. Okay, so let me prove this result. The proof itself follows the same idea as the previous proofs, okay, that I went through in the previous videos. So let's go through the proof together. So let me break it down into steps to make it more understandable. So step number 1, I let y equal the inverse hyperbolic tan of x, okay, and I rewrite that as hyperbolic tan y is equal to x. So that completes step number 1, okay. So now we need to use the definition of hyperbolic tan to find an expression for hyperbolic tan y. So in one of the videos previously, hyperbolic tan has the definition e to the x minus e to the minus x divided by e to the x plus e to the minus x. Okay, so therefore tan y will have the definition e to the y minus e to the minus y divided by e to the y plus e to the minus y. That in turn is equal to x on the right hand side. So if you looked at the previous videos for the inverse hyperbolic functions, sine and cos, how I proved them, the idea in step number 2 is to make y in terms of x. So if we make y in terms of x, you will have the definition or the result for the inverse hyperbolic tan function. Okay, so what I'm going to do is, let me cross multiply to give me, when I cross multiply, sometimes I like to put some brackets there to be on the safe side. So if we cross multiply, we're going to have e to the y minus e to the minus y, that is equal to x into e to the y plus e to the minus y. Okay, if I expand the brackets, e to the y minus e to the minus y will be x e to the y plus x e to the minus y. Okay, now I don't like negative powers, so I'm going to get rid of these negative powers by multiplying the whole equation by e to the plus y. So if I multiply throughout by e to the plus y, we're going to have e to the 2y minus 1, that is equal to x e to the 2y plus x. So bearing in mind e to the y times e to the minus y is e to the 0, which is 1. Okay, e to the y times another e to the y is e to the 2y. So if you looked at the previous videos again on the proof for inverse hyperbolic sine and inverse hyperbolic cos, we created a quadratic equation. Now in this result, you're not going to have a quadratic equation to solve. Okay, so what I'm going to do is, we're going to take the e to the y terms or the e to the 2y terms to one side, taking the remaining terms to the opposite side. Okay, so if I take this x e to the 2y to the left, I'm going to have e to the 2y minus x e to the 2y, that is equal to, moving the minus 1 to the right will give me 1 plus x. Okay, so I hope you can see that. Now from this point onwards, I'm going to take e to the 2y as a common factor, giving me 1 minus x, and that is equal to 1 plus x on the right hand side. Okay, and what I'm going to do now is, let me make e to the 2y the subject, So if I rearrange, e to the 2y will be 1 plus x. Okay, so I hope you can see that. So 1 plus x divided by 1 minus x. Okay, and from this point forward, we can make 2y the subject by taking ln's or logs on both sides. So if I take ln's on both sides, 2y will be ln of 1 plus x over 1 minus x. Okay, and if I rearrange for y, therefore y will be 1 over 2 ln 1 plus x over 1 minus x. Okay, so if you remember, y is the inverse hyperbolic tan function. So if I replace y here by the inverse hyperbolic tan x, we've got the result. So therefore, hyperbolic tan inverse x is indeed 1 over 2 ln 1 plus x over 1 minus x. Okay, so that completes the proof. Okay, so I hope you found this video helpful. Okay, and I hope to see you in the next video. Thank you.